Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be talking about viewing 2D sediment results. So what I have on the screen here is a page from the HEC RAS 2D Sediment User's Manual, and I'll go ahead and leave a link to this page in the description of the video if you want to read along. All right, I'm going to minimize that window, and now I have my RAS mapper window up. I've already ran a model with sediment in a 2D flow area, as you can see here. I'm going to go ahead and toggle off the terrain layer so you can see the map extents, and you can see it's flowing from east to west. What I'm going to do is show you the model, run the model, and then we're going to go ahead and look at some of the results. So let's go ahead and take a look at this model real quick. I'm going to go up to Edit and then Unsteady Flow Data. What I have on the upper boundary condition line, the upper edge of the flow, it's going to be a 3-day simulation. So the flow rate just increases from 1,000 to 1,400, or I guess 1,300 over the course of 3 days. I got one extra data point there I don't need. And then the downstream boundary condition is just going to be using normal depth. So as for the sediment data, here are my boundary conditions. The upstream uses a sediment time series, and over the course of 3 days, that sediment load is going to start at 1,000 and then increase to 2,000, and that's tons per day. And then as far as the makeup of that influx of sediment, it's going to be 50% very fine silt and 50% fine silt for the entire range. I just made a range from 1,000 to 4,000 to include these values here. All right, so let me go ahead and close that. And then the 2D bed gradations. The previous lesson or lessons I've talked about how to define this, but basically I'm going to have 6 feet of material to define to a road, and that's going to be 100% particle 5, 7, or 9. So as I've defined those is right here. So 7, for instance, is 100% fine sand, and 5, for instance, is 100% coarse silt. That's how I'm doing that. Okay, so let's go ahead and run the model. I'm going to go ahead and click on the stick figure that's running up the hill. That's the unsteady flow analysis box. I'm going to make sure to check on my sediment checkbox right here. I'm using the base layer, the one and only sediment file I have in this project. Also, for some of my sediment computation options and tolerances, I just wanted to point out I'm using a multiplier of 10 here, which means I'm not computing sediment every single hydrologic computation time step, but 1 in every 10. So 1 minute, it's actually going to be computing every 10 minutes. Over in the 2D tab, I'm just going to be using the default values here. Okay, and there's also a warm-up period that's included. But enough of the precursor. Let's go ahead and click the compute button and run the model. Oh yeah, so I should probably also mention right here, I'm using shallow water equation, ELM equation set, not diffusion wave. It gave me a warning when I used diffusion wave. And then for the transport method, I should probably also point out I'm using the England-Hansen method. Okay, so that finished up. There was no errors, no warnings. Let's go ahead and check out some of those results. All right, so what we have on the screen is the default results, which I already had loaded. Over here in this left panel, we can go ahead and click on results, click the plus to expand. And then right here are the names of the 2 different plans, WSEL 20 and then flow 1K to 2K. Those are just the names of the plans. I can collapse and expand the layers within each plan. Now we have the event conditions, geometry, plan, and then all the results layers. These 3 results layers are the default results layers, which is velocity, water surface elevation, and variable depth. But these are all related to hydraulics. And what we're interested in this lesson is the sediment data. We can add layers of sediment results to our plan. If we go up to the plan, I'm just going to go ahead and click on the plan name, right click, and then click on create a new results map layer. And now what you see here is we have a category for hydraulics, sediment, and then additional 2D variables. I'm going to expand sediment, and now I have sediment bed and sediment transport. Sediment bed maps right here. This includes results like bed change, bed elevation, bed gradation, and other bed properties. So you can see we can go ahead and click on any of these, like bed change. That represents the elevation change in the bed over the course of the simulation. Now I can specify an individual profile and then save it as a static raster file, which is like the full data that you can zoom in on and get the exact enhanced values at every single cell. Or what I could do is just use the default setting, which is the generate for the current view in memory, which is a dynamic layer, it's not saved, but what it is, it will render on the fly based on your zoom level. So the values may not be exactly the same as the stored data unless you zoom in all the way to see individual cells. So I'm going to go ahead and keep the raster radio button here selected right here. That will allow me to animate the results the same way I can already animate the results for the depth, the water surface elevation, and the velocity, those three default hydraulic layers that were already added to our map. Okay, the name of the layer is going to be called bed change. That's fine, that's what it is. So I'll go ahead and click add map. It tells me successfully added one map to that plan. That was the name of the plan. So I'll go ahead and click close. Now here is the bed change results. So the range for the legend here is showing me 1.24 to negative 1.24. That is the default color scheme for this particular variable. We can change that. Let's just go ahead and click the play button and see what it looks like. Okay, so not a whole lot of results. The simulation has completed. Took about 3 or 4 seconds to run through. If I zoom in at the very beginning, this is the very upstream end of the reach here, and then I click on it, looks like 1.24 was the maximum, but it looks like it's front loaded, meaning the influx or the gradation of the inflow is too heavy and the flow velocity was not enough to actually carry that sediment further downstream. Also, there's no red, which means that there's really no erosion taking place. It's just deposition, which is the positive value. There may be a little erosion at the very end. Yes, there is. And this is only because I set the downstream boundary condition. It's using a slope that's higher than it actually is. So that's why we're getting a little bit of erosion. The velocity probably peaks right here at the very end, and that results in higher shear force along the surface of the bed. Okay, I'm going to add another layer. Next up is the total load concentration. So I'll go back to my plan, right click, create new result map layer. And then in sediment, let's go ahead and click on sediment transport. And sediment transport includes results like concentration, capacity, and other results that are dynamic, water column, and flux results. It's what I have in my notes here. So what we have is total capacity, concentration, transport capacity, and total load transport rate. If you notice there's a plus button next to total load concentration, and that's because it further divides the results, not just the total, but also the individual grain sizes. Now, what you're seeing here is just the grain sizes that I have in the model, which is fine silt, fine sand, and coarse sand. I'm going to go ahead and add all of these. So I don't want to actually select an individual value. I'll just select this total concentration. And then I'm going to go with raster over here to allow me to animate the layer. And then down below here, I can also modify the labels. I'm going to go ahead and modify the labels just a little bit, just so we can see that it has been changed. I don't think I've ever demonstrated that in a lesson before. So to figure out which number corresponds to these different layers or these grain sizes, I'm going to go up to the sediment real quick, click on gradations, define a gradation. So the fine sand, for instance, is number 7. And then the coarse sand is number 9. Okay, so that's good enough just to demonstrate the label. I'm going to go ahead and close this. I'm not going to actually make any sediment changes at the moment. So fine sand right here, I'm just going to double click and I'll just put a 7. And then after CS for coarse sand, I'll just put a 9. All right, just demonstrating how this works. All right, going to go ahead and click add maps. That's been added. 6 separate map layers, it says. So I'll click OK. And then I'm going to toggle off the bed change and then toggle on this total concentration. So I've zoomed out a little bit here. Looks like we have a coloration of blue. Let's see what that means. I'm going to expand. Okay, so blue is the lower end of the concentration, and then yellow is the upper end of the concentration. What I'm going to do is toggle off the individual grain sizes and just look at the total to start with. So when I clicked on total, it now gave me this range, this color ramp of different concentrations from 0 up to 857 milligrams per liter. I have a strong sense that that maximum concentration is going to occur in the upstream end. So let's go ahead and run the animation again. Click the play button. All right, so we're about day 2, day 3, and it's over. So that wasn't particularly satisfying just because the color ramp really only changed at the very upstream end of the reach. What I want to do now is change the color ramp, and to know what values to use, let's go to the middle of the map here and just hovering over these values, it says 95. Now keep in mind, this is the end of the simulation. So 95. At the very downstream end, we're down at 50. Near the upstream end, we're still at 100. And then at the very upstream end, we're up to 500, 800. So let's go ahead and say maybe 100 is the maximum. Everything over 100 gets the maximum color, which is in this case is yellow. So to do that, you can modify the symbology. You can either double click on that layer and bring up the visualization and information tab. You can access the same dialog box by just going right click and then layer properties. And then it's the first tab here, visualization and information. Now to change this color ramp or to modify the range, go ahead and click the edit button. As you see, the default range for min and max is already set and grayed out. Min is 0, and that's probably fine. Maximum is 857. What I want to do is check that, use the data set for min max, and I'm going to just manually change the numbers here and then change it to 100 and then click on the create color ramp values. So that updated these values right here. Everything over 100 is going to just assume this maximum value of this yellow color. And I can go ahead and manually change these colors using the RGB numbers, or I can use the color ramp. The min-max values that I just specified will work for the discrete symbology as well as the stretched, like continuous coloration. So we're using the stretched or the continuous right now, because if I click OK, you see stretched is what I have selected. And then the other option is called discrete. All right, so let's go ahead and see what this symbology looks like. I think it's already saved, so just clicking OK is good. And this right here is the final map. Let me go ahead and run it back so we can see the animation in action. So I'll go ahead and click play. Okay, so that's day 1 end, day 2, and the final day is right there. If I'm interested in the individual contribution from the different grain sizes, then I can do that as well. And I would just go ahead and say, okay, here's the very fine silt, select that. And it looks like the maximum at the end of the simulation is about 400. Again, it peaks at the upstream end. So what that tells me is I need to either have higher flows or change the sediment load such that more of it flows downstream and doesn't pause it immediately. All right, let's go ahead and add one more layer. So again, create a new results layer. Let's go back to sediment and then sediment load. Okay, so we have bed chain. Let's go ahead and go with bed elevation and again, make it a dynamic layer. So add to map, close. Actually, there is one more thing I wanted to look at when it came to the concentration. So let's go back to total concentration. The new layer that loaded in here, I'm going to toggle that off and then click on total concentration. And then what I want to do is look at the time series. So what I can do, just like hydraulic results, is I can hover over any cell in this 2D flow area during the simulation, and the value that's labeled right there in magenta, right by my cursor, 256, it will be changing as the animation plays through. So let's go ahead and do that. I'm just going to go ahead and click the play button now. And then it says 205, 314, 319, 333. I don't know if you saw that it went kind of quick, but another way to look at the values in a time series plot for any cell or cell face in the map is just to go right click, plot time series, and then you want to select the actual variable. This is the entire list of variables. So we have water surface elevation, velocity, and depth. These are grayed out only because they're unchecked over here. But if I went ahead and checked them on, like velocity, water surface elevation, bed change, bed elevation, and then go ahead and right click, plot time series. Now I have the ability to actually look at that time series data. But I wanted to look at the total load. So let's go ahead and look at that. Here is this is what I was expecting to see. So for the first 24 hours, we have that, 1,000 tons per day. And then starting at the second day, we immediately increase the concentration at that upstream boundary condition to 2,000 tons per day or whatever it was. It was doubled basically. And we see that in the results right here, partially because the location of this time series that we're looking at was taken very close to the upstream end of the reach. So we have this dramatic increase in concentration. Now, if I looked at the same table further downstream, maybe twice as far downstream, right click, and then total load concentration total, we still see a jump, but it's not quite as pronounced, partially because some of that sediment has settled down and we just don't see it as dramatically. Now let's double the distance once again, just kind of eyeballing it here. So maybe right here, right click, time series, and then let's check out that. Yeah, at this point, you can barely see the increased concentration. I mean, it's noticeable, but not nearly as distinct as it was with the previous two plots. Let's take a look at that bed elevation now. So I'm going to toggle off all the other layers and then click on bed elevation. So here's the range of values. Now, I don't really care too much about the elevation in this overbank area. I'm just interested in the elevation in the stream itself. So what I'm going to do is modify the scale again, but I want to get an idea of what range to use. Obviously, it's not going to be a difference of 25 feet like we have here. It's going to be closer to whatever the green color is in the map, which is closer to like between 15 and 20 is my guess. If I go up to the upstream end and go right click, cell bed elevation, I can get the plot. So that starts at 15.72, and then it increases with all that deposition up to 16.07. So we'll say the max is 16.1. And then at the downstream end, let me go ahead and move over there. I'm going to go with a right click and then check out that cell bed elevation. Oh, that actually decreases quite a bit because of that erosion I was talking about. 15, we'll say 15.5. So 15.5 to 16.1. All right, so now we can update the minimum and maximum value on that cell bed elevation. I'm going to go ahead and click Layer Properties and then click on Edit and then uncheck this box so I can manually make the edits. What did I say? 15.5 and then for a maximum 16.1. Okay, and create values and then click. Actually, if I wanted to save this color ramp, I can also do that by clicking on Save Color Ramp. My color ramp 1. Okay, sure. Okay. And then I'll click OK and then close this. So everything in purple is well over the 16.1 elevation. No surprise there. And then everything that's yellow and green is ranging from well, like maybe 15.8 down to 15.6. Okay, so this is the beginning of the simulation. During the simulation and at the end, we should expect some sort of a smoothing out. So I'll go ahead and click the play button. And we see the colors changing a little bit, especially in this upper end. So it's no longer a stair step. It looks more gradual in the coloration. So now if I go back and select my polyline layer right here, then select the polyline, zoom in, right click, and then cell bed elevation. No longer do we have like a stair step look. What we have is a much different look where at the top of the reach, that's where most of the deposition took place. And then down here, it looks a lot more gradual. Next, I want to sketch a profile line across the river and show the cross section. So what I'll do is I'll go up to profile lines, click on edit, go ahead and sketch a line like so. Profile line 1, that's fine. Select that profile line. The variable that I want to plot here is needs to be toggled on here if I want to see it. So let's look at how about total load. So I can just go ahead and click on this. Plot profile, total load. Here we have a cross section of the total load. So where there's no flow, there's no concentration, and you can see how the concentration increases as the flow and the depth increase and then back down to 0. That's just for this particular cross section and then just for this particular variable at the last time step of the simulation. All right, the last thing I want to demonstrate in this video is viewing composite sediment time series results with a reference line. So to do that, we go up to our geometry, which is called base, and then begin edits. Looks like it's already in edit mode. Click on reference line. And now what I'm going to do is draw a reference line across the river. And this needs to be done before you run the simulation. So I'll go ahead and draw the reference line. Reference line 1, that's fine. I'm going to go ahead and stop the edits, click Save Edits, and then I need to run the simulation once again so that the results can get saved with regard to that reference line. So bear with me just a moment. I'll go ahead and click Run and Compute. Right, that finished up. I'm going to click on Close and then close this dialog box. Now in the main File GUI window, I can click on the hydrograph button, which is this one right here. And actually, I can also open this window up by going up to View and then Stage and Flow Hydrographs right here, same dialog box. Next, what I want to do is click on Type and change it to Reference Lines. Wait for it to do some computations. And then what I have is velocity and elevation. This is pretty boring, but what I want to select is the reference line 1. That's correct. It's the only reference line I have in my geometry. And then for options, I want to click on variables. Now what I have is a list of different variables that were already computed with respect to that reference line. So for instance, I can select maybe the total concentration right here. And then if I click OK, it adds that plot. So here's the plot of that concentration. Here's the little increase slope right here at the beginning of day 2 where the increased sediment happened. But you can tell that this reference line is fairly far downstream from that upstream boundary condition where the more dramatic results from that increased concentration were noticeable. If we wanted to confirm these numbers here, like the concentration, it looks like it goes from maybe 75 up to maybe 240. Let's see, if I hover, it tells me 56, I'm sorry, 56 up to 224. Okay, let's go ahead and close this dialog box and then zoom in near this reference line. If I select on reference lines and then come over here, I can select a cell face. And then here is the cell face properties, which should have similar concentration to the reference line because it's just so close to it. I want to click on plot time series and then come down to total load concentration, total load. And here we have similar numbers. Looks like it starts down around 50 and it ends up around 250. All right. So anyway, there's table results right here as well, just as you typically see in these sorts of results windows. Well, that's it for this lesson. What we talked about was viewing 2D sediment results in HEC RAS.